dear students, to begin this session, we start with differentials, and there are 3 segments in differentials: limits, continuity and differentiability. In differentiability, and this exercise 10.1, this exercise 10.1, sum number 3, test the function is differentiable at the point f of x equal to mod x plus mod of x minus 1 at x is equal to 0 and x is equal to 1. Now, we wish to define about this function. First of all, the function is mod x and mod of x minus 1. You can draw this one in graphical way also, mod x minus 1, this is mod x minus 1 is, so one thing just shifting like this part. So, combine this function only, this one mod x plus mod of x minus 1, and they ask you to find at x whether the function is continuous differentiability, at 1 whether the function is differentiability. This is what the question, the combined function of mod x and mod of x minus 1. How to take this value here? Now, let us see this. Now, the function is what? F of x is equal to mod x plus mod of x minus 1 at x is equal to 1 and at x is equal to 0 and x is equal to 1. Two values we have to find whether the given function is differentiable or not. Differentiable at x is equal to 0, what we do? Differentiable or not, that means we have to check so many things here. So, let f of x is this one. That means first of all let us define about the function x less than 0. X less than 0 means x plus x minus 1. If x is greater than or equal to 0, that is here minus bracket this first of all, and here x plus x minus 1, remember that. That means here x and x plus 2x minus 1, 1 minus 2x, here x and x 2x minus 1 if x less than 0 and if x greater than or equal to 0. Remember that there are two functions f of x. F of x 1 minus 2x, 2x minus 1 if x less than 0, if x greater than or equal to 0. So, that means here we want to know whether it is a differentiability or not. So, let us think over, let us take this one. What is differentiability means what we have to prove? Left function and right function, both values of f dash of x, that is at x is equal to 0, we have to check L of f dash of 0, R of f dash of 0 is equal to 0 mean it is differentiable, if not, not differentiable. But the condition for the problem, the function is differentiable at x is equal to 0 and x is equal to 1. That means two things we have to find, whether it is differentiability at x is equal to 0, differentiability at x is equal to 1. Now, at x is equal to 0, that means L of f dash of 0. So, this is according to the definition of this, limit x tends to 0 plus f of a plus del x minus f of a by del x. This is what we are taking the definition. Why I am just inclined with the definition? The definition will be very helpful for doing this sum. So, whenever you do any kind of problem, this definition only is carrying over the problem too. So, that means here limit x tends to 0 minus, because it is left limit, so 0 upon. So, here f of x minus f of 0 by x minus 0, like this I can write first part. So, this is the definition which I am carrying out from here. So, left limit this one, actually from the left limit I am just taking this one. Now, it is over. Next stage what I should do, I should just think about each part of the f of x. F of x means this is the one I am going to take because of left limit 1 minus 2x. Now, limit x tends to 0, that is 1 minus 2x minus f of 0, that is 1 minus 0, that is here whole divided by here x. X is what? This part. X is x. Let it be here as x. Now, here 1 minus 1 getting cancelled, it is minus 2x. That means limit x tends to 0. Remember that 1 and 1 getting cancelled, minus 2x x and minus 2. When you are applying x is equal to 0, its answer is minus 2. This is 1 for left limit. And for right limit, I wish to take r of f dash of x. R of f dash of x, I just take the f dash of x means x is equal to 0 here. So, that means I should write over here as 0. And now we have to write from the definition, this one. We have to carry over the definition. So, that means limit x tends to 0. So, here this part f of x minus f of 0 by x minus 0. Here limit x tends to 0 plus f of x. What else we have? It is 2x minus 1. Now, this is the function 2x minus 1 minus 0 minus 1 whole divided by x. Now, we take this here 2x minus 1 minus of minus plus 1 whole divided by x, limit x tends to 0 plus x and x getting cancelled, it is 2. So, here it is 2. So, r of f dash of 0 here. So, left limit we carried over minus 2 and right limit we got plus 2. By seeing these two, what you understand? It is not differentiable. From 1 and 2, we can see that L of f dash of 0, R of f dash of 0 is not equal, that is minus 2 is not equal to plus 2. So, both values are not equal. So, f is not differentiable at x is equal to 0. X is not differentiable at x is equal to 0. Next one more thing we have to check at x is equal to 1. First we took x is equal to 0, now at x is equal to 1. The same definition continued for x is equal to 1 to check whether the function is differentiable or not. That means L of f dash of 1, limit x tends to 0 minus, that is f of x minus f of 1 whole divided by x minus 1. F of x means first we have to consider this, because left limit means x less than 0, 1 minus 2x. So, 1 minus 2x minus 1 minus 2 into 1 whole divided by x minus 1, limit x tends to 0 minus, remember that. So, here plus 1 and minus 1 is getting cancelled, minus 2x minus of minus plus 2x plus 2, here minus 2x plus 2 over x minus 1, limit x tends to 0 minus. That means limit x tends to 0, here minus 2 if I take common, it is x minus 1 by x minus 1. So, cancelling these two, I am getting the value is minus 2. Result is 3 here. So, now I found out the value of 3. So, for the left limit for 1, I got value minus 2. So, let us take the other one, r of f dash of 1. Limit x tends to 0 plus. So, now we got the value for 1 here. Now, let us take for right limit f of x minus f of 1 by x minus 1. Limit x tends to 0 plus. Here right limit. What is right limit here? 2x minus 1. Remember that 2x minus 1, this function. So, 2x minus 1 minus 2 into 1 minus 1 by x minus 1. The value of x, I am just substituting the value of 1 over there, and minus 1 and plus 1 getting cancelled, these two. So, limit x tends to 0 plus 2x minus 2 by x minus 1. Like this I got. You take 2 common. So, if I take limit x tends to 0 plus 2 bracket x minus 1 by x minus 1, both are getting cancelled, it is nothing but 2. So, here it is fourth one. Third one we got minus 2, fourth one we got plus 2. So, from 3 and 4 we observe that L of f dash of 1 is not equal to R of f dash of 1, because it is minus 2 is not equal to plus 2. Therefore, f of x is not differentiable at x is equal to 1. So, f of x is not differentiable at x is equal to 0 on the first case. Now, f of x is not differentiable at x is equal to 1. Let me recapitalize right from beginning. You have to define the concept of what is differentiability. Better you consider both left and right limit of both. This is left limit, this is right limit. Knowing about these two, we have to bring it to the application part, that is very important. So, this is the function, modulus is given. First we have defined the function in such a way that less than 0 means first one appears, greater than or equal to 0 second one appears. After simplification I got the function like this. This one I have taken into consideration for the problem x is equal to 0. Now, left limit of f dash of 0, right limit of f dash of 0, knowing about two values and both are not equal, that means it is not differentiable at x is equal to 0, first part. Second part, we want to check for 1 also, that means at x is equal to 1, left limit of f dash of 1, I have defined the function based on that, that is right limit. I have taken each function and substituting the value of x over 1, and I found out after simplifying I have got the value minus 2. Likewise, right limit of f dash of 1, applying the function definition and knowing about the function what we have, substituting, got the result of 2, and 3 and 4 we compare, they are not equal. At once knowing about the result of left and right, that means f is not differentiable at x is equal to 1. So, in this way only we can do this kind of differentiable problems. Students, you should know the basic concept of differentiability, so that In any kind of problem when you come across, you can do sums like this way, very simple way.